Hello students, today I am going to discuss a different practical, BSc Physics practical, and object is to study the resonance in a series LCR circuit and to determine its quality factor. So what are the apparatus? We need an audio oscillator, this is audio oscillator, a milliammeter, voltmeter, and this is series and parallel resonance circuit. Here we observe that resistance, inductance and capacitance, these three are in series, so we directly use this circuit. Here are three values of R: 10 ohm, 510 ohm and 1500 ohm, and these L values and C capacitance values. So first we connect the circuit in this way. Audio amplifier connected to this series and parallel resonance circuit, and a milliammeter connect in series. Now what is the theory of this? In a series LCR circuit, the potential difference across the ends of the resistance R is measured and the current flows in the circuit is determined. When we plot a graph between the current I and the frequency of the applied EMF, in this curve, the frequency corresponding to the maximum current is known as the resonant frequency omega R. There are two frequencies omega 1 and omega 2 on two sides of resonant frequency, which the value of currents becomes 1 by root 2 of its maximum value, like this. This is the maximum frequency and the maximum current, and the current were 1 by root 2. These are half power points F1 and F2, and this is the resonance frequency FR. These points in the resonance curve are known as half power frequencies. From resonance curve, quality factor is given by Q equal to omega R upon omega 1 minus omega 2, or we can write FR upon F1 minus F2. Theoretical, this is our practical value, and the theoretical value of Q is omega R L upon R, omega को 2 pi FR L upon R. We know omega R equal to 1 upon under root LC. Then FR we can write FR equal to 1 upon 2 pi under root LC. So this is the theory. Now we make observation table. Inductance, we set inductance suppose at 100 millihenry, and the capacitance is 0.002 microfarad. These are the values, and on different values of R we take reading of milliammeter by varying the frequency input. This is the audio oscillator. We on the power, and now different values of frequency. So first we put the resistance at 10 ohm, and we note the variation of different frequency input of milliammeter. Here when we increase the frequency, ammeter reading showing increases, and suddenly it is decreases. Here we get a peak of maximum value of current, and we note the readings, and then we put it at 510 ohm and same reading we repeat it of same frequency so that we can easily draw a graph. Here we observe a same pattern and then we change it at 510 ohm and then we get a same pattern of frequency. Now we switch off the power and this is our observation table. Now we take calculation. First we draw a graph of this type at 3 different resistances. We draw a graph. We get at minimum resistance to 10 ohm I is maximum, and at I maximum upon root 2 we get 2 half power points. Then we get value of F1 and F2. So theoretical value of quality factor is given by this formula, Q equal to 2 pi FR L upon R. We put the values of L and R and we get quality factor. And for practical values we use this resonance curve. Practical value of resonant frequency FR we note here. Half power frequencies we note F1 value and F2 value. And practical value we determine by applying this formula FR upon F1 minus F2. And after this we write result from this type. It is inferred from the graph between current I and frequency F that first, as the value of R decreases, the value of current at resonance increases and the resonance becomes sharper, that is the value of Q comes out to be larger. At different values of R, we have write down the values of Q. And the second point is for various values of R and resonant frequency, the theoretical and experimental values of quality factor come out to be almost same. Okay, thank you.